So we're creating a push button operator. A push button is a boolean. Create it, and we want to start a timer. So we do go to timer on, create operator AT on, then we want it to be a timer T on, create, and we want it to be a 3500, 35,000. So for example, we just make it 3 second, 3500, 3500 milliseconds. That's about 3.5 seconds. And once that timer is done, that operator T on is done, we want to start one more timer. Say we call it operator B timer, and now we want that to be 7500. We'll make a new timer, new, create new, and we want it to be 7500. Since timer done bit will be only on for small amount of time, let's see what this would do. So we'll go ahead and toggle simulate a push button by right click toggle bit, and once this reaches 3500, the timer done is completed. Then we start a 7.5 seconds. Now the question is, after 7.5 seconds, should this 3500 timer restart? If that's the case, then all we need to do is not off operator B timer done. So now what that would do is it will keep it 3500, and then it will wait for 7.5 seconds, and once this done is gone, it will start. So this will keep looping. Every time operator A pushes a button, 3500 second starts, and then 7500 timer starts. So that's how you play with timers. There are several ways to do timer programming. One of the question I had was operator A pushes the button. We start a timer on for 3500, and then once that timer is done, we'll start one more timer for 7500 milliseconds, and then once this timer is done, this will go low, which will keep the other timer running. So that's how we do the timers. And if you want to trend these, you could right click, go to monitor operator a timer on, and then extend, and you could trend the accumulator bit, and you could right click and do trend, and once you run it, you can see the 3500 will make the chart properties on x-axis to be minutes. Apply, okay, and you could see how the timer is timing all the way up to 3500. And similarly, you could trend operator B timer on dot ACC add, okay, apply, and you could put them on individual scales by using the isolated graphing. So you go to y-axis isolated graphing, and on x-axis, and you could give 1%, and on x-axis you could on general, I think on display, make sure you have milliseconds. Apply, okay, and run this trend, and you could see once the 7500 timer is done, we'll start the 3500 milliseconds, and then the loop continues. So the accumulator is maintaining at 3500, and it went to low, and then restarted again once the 7500 timer is completed. Hope this answered the subscriber question. Sorry, I could not get my mic working, so I had to close the previous stream and open this stream again. Time between So I'm answering a question from the subscriber, which the scenario is an operator pushes a button. We start a timer for 3.5 minutes. For sake of video, I just made it 3.5 seconds. And once that timer is done, we will start one more timer for 7.5 minutes. And I think for the video, I made 7,500. And once this timer is done, all I have used is the timer not done, which would be uh, low for a for a scan. That's long enough for this timer to restart. So now we are in a loop until operator A takes his button, takes his hand from the button. So that's how it works. To start a timer, we go ahead and push the button, the timer starts, and then once the timer is done, the operator take I have input 0 connected, so let's directly use local 1. I have wired a push button to input 0, which is a start button. I'm pushing that one. So we go ahead and assemble the rungs. So operator pushes the button, and once the operator lets go of the hand from the button, the timer stops timing, right? So to avoid having that, the moment we have the timer starting, we can use the timer timing bit. So now what will happen is the operator can let go and the timer keeps so once the operator pushes a button, we use the timer timing to start the timer. And once this timer is done, we want to start timer B, and we can use the timer B. Once it starts the timing on timer B, we can keep the timer self timing. So let's see, operator push a button, let go of the button, 3500 times out, timer B starts and ends the timer after 7500, and the cycle won't start until the operator pushes start button on the operator A. So that's how you can use timers. The same logic can be done using latch and unlatch. You could use a latch memory bit to latch timer A done, and then after timer B is done, you could unlatch the latch bit. So if you have any questions, please post it in the chat and I'll do my best to answer those questions regarding timers. So again, we'll go through timers. They are useful in developing logic, and we use timers as a debounce timers. Say if you have a sensor and you want to make sure the signal from the sensor is settled before you call it a object being blocked on the photo eye, we just use a debounce timer to ensure the signal is on. Say for example, if we have a photo eye on the field which is shooting a laser line and on a box, and then once it sees the box it will give us a signal. Sometimes the photo eye might be getting reflection and it won't make steadily, so to add a debounce timer, we to debounce it to make sure it's seeing the box for 500 milliseconds, we use something called debounce timers. So we use debounce, you can name it whatever you want. I just call it debounce photo eye, and once the timer, and we create new timer base and we say 500. So once the photo eye is made for 500 milliseconds, then we can use the signal for in our logic. So we could just use that signal photo eye done bit, and we can use the debounce photo eye dot done as photo eye made, and we just call it. So what that would do is I toggled it, and if photo eye is flickering, you would never get the photo eye made. So that's how you understand if that's how you block any reflections of the reflector, or if the photo eye is seeing anything shiny, you could prevent getting a nuisance detection. So debounce timers are useful to filter out any disturbances with the photo eyes. Okay, that's one purpose of debounce timers in practical machines. Please let me know if you have any questions in the comments, and I'll try my best to answer, and I could at least provide you a methodology of how to handle some of the logic you will be using in practical applications. And always make sure you use good practices where you add run comments. This is a debounce timer to ensure the signal from photo I is made at least 500 milliseconds before we call it the sensor is blocked. And always write down your initials and a date. That would help whoever is seeing the logic. So that's one of the good practice. And if you could become fancy with this, you could to make it look good, we typically use a star marks like this, and it looks much better like this way. This live stream is going to end in a couple of minutes, and I will go online again tomorrow around same time to answer any questions live.